Hello, another AQA A-level physics question on the topic of mechanics. If you want to choose a different question, click on that information card there. If you want to try and do the question yourself, pause the video now. If you've got the answer B, well done. Here's my explanation. The drag force on a boat is kV squared, where V is the speed and K is 64 kilograms per metre, so K is a constant value. The boat's engine has a useful power output of 8,000 watts. What is the maximum speed of the boat? So let's have a look what's going on here. Well, we've got a boat and it's sailing along. So it's moving in that direction with a certain velocity, and there's a drag force trying to stop it moving in that direction, and that drag force is equal to kV squared. It makes sense that drag force has got the numbers kV squared, because it's saying as it goes faster, as its velocity increases, that force on it increases. So there's a power trying to pull it forward, and when the forward force produced by that power of 8,000 watts equals the backward force due to the drag of the water, then it'll have reached its maximum speed. We could even call that its terminal speed or its terminal velocity. Okay, so we're going to use the equation from your data sheets that power is equal to force multiplied by velocity. We're trying to find the velocity, so I'm going to rearrange that to say that the velocity is equal to the power over the force. Now we can put some things in here. We know what the power is. We know the power is 8,000 watts, and we know the force is given by this value kV squared, and we're told K is 64. So instead of force, I could write 64 V squared. I can rearrange this equation to say that V cubed is equal to 8,000 over 64. So that gives me a value of 125. So V is equal to the cubed root of 125, which is 5 meters per second. Answer B. Thank you for watching. I hope that explanation was useful. If it was, hit that subscribe button please. Share with your friends, hit the like button, and watch for more of them in the series. Thank you for watching.